part of our spacecraft series. And in our last two parts, we saw about what is a spacecraft and what's Kennedy Space Center and some other stuff like roll in, roll out and how the spacecraft is arranged. In our today's video, we are going to see after the rollout in the launch pad, what are the things there? What happens before the launch? So let's stick to the point and dive right in. The mobile launch platform has large holes for the rocket flames. The three main engine flames will go through this hole, and the flames from the two SRBs will go through these holes. Below the pad is the flame trench. During liftoff, the flames will be deflected to each sides. The structure next to the shuttle stack has two main parts. The fixed service structure, which does not move, and the rotating service structure, which can pivot around to completely enclose the space shuttle. Sometimes the payload were loaded here in the vertical position, and other times they were loaded before this when the orbiter was on the ground at the OPF. The fixed service structure has a lightning mast on top and three other service arms. Two of them are vent arms, which will collect excess hydrogen and oxygen from the external tank. This is the gaseous hydrogen vent arm with the umbilical carrier plate at the very end, and this is the gaseous oxygen vent arm. Because the fuels are very cold, the beanie cap is really important to prevent ice building up at the very top. The third arm is called the orbiter axis arm. At the end is the white room. This is how the astronauts get on board the orbiter in preparation for the launch. Down here are the two tail service masts. They have connections to each side of the orbiter. On the day of launch, this is where the fuel will come in to fill the orange external tank. If there is an emergency on the launch pad and the astronauts have to get away in a hurry, they'll come over here to the emergency egress system. It has several baskets that can quickly carry them far away from the launch tower. Each basket can hold up to 3 people. One more feature of the mobile launch platform is that of the sound suppression system. Beginning at just a few seconds before launch, water will start pouring out of a few different places. This will limit the sound shock waves from bouncing back and damaging parts of the shuttle as it leaves the ground. The water is stored in this large tower on the launch pad. Now let's see how this works on the day of the launch. There are many things that have to happen in order. I can't cover them all in this video, but let me show you some of the main ones. At T-5 hours and 35 minutes before the launch, fuel begins loading into the external tank. The fuel comes from the white spherical tanks on the edges of the launch pad. Remember that the SRBs already have their solid fuel inside them. At T-3 hours, the astronauts leave for the launch pad and begin to enter the orbiter vehicle. Since the shuttle is vertical on the launch pad, all the seats are in the laid back position. Most missions had 7 astronauts, 3 in the mid-deck and 4 in the flight deck. There are no windows in the mid-deck, so some astronauts won't be able to enjoy the view on the way up. There is a lot of excitement coming up to the moment of liftoff. However, if there are any problems such as mechanical failures or even bad weather, the launch will be delayed or even cancelled to another day. This is called a launch scrub, and it can happen all the way up until just a few seconds before liftoff. At T minus 7 minutes and 30 seconds, the orbiter access arm is slowly retracted, and if there is any emergency, they can quickly bring it back into place. And at T minus 3 minutes and 45 seconds, the main engine gimbal test is done to make sure that everything is working correctly. And after that, at T minus 2 minutes and 55 seconds, the beanie cap is lifted and the gaseous vent arm is retracted. At T minus 10 seconds, they activate the hydrogen burn off system. And no, this is not actually to start the engines. That happens up here inside the combustion chamber. What these sparks do is ignite any excess hydrogen. This can cause an unexpected explosion at the launch if it isn't taken care of. At T minus 6.6 seconds, the three main engines ignite. All the three must work correctly, or else they'll shut them down and abort the mission. At the moment of liftoff, many things happen simultaneously, but this is saved for the next video, so stay tuned. Well guys, our video is over. Did you feel it good? Leave it down in the comments below, and don't forget to like, share and subscribe. In our next video, we are going to see about the things that happen at the launch, the simultaneous stuff. So, stay tuned. Vijay signing off.